Hi. Welcome to the lecture on Chapter 1, Network Defense and Countermeasures. That's the name of the textbook, but this one is just giving you an introduction to network security. Hopefully this chapter doesn't scare you too much because most of you have gone through one, if not two, or more networking classes. And networks are a chance for breach of security. So we're going to look at in this chapter, identify some of the most common dangers for your network. Just dust off some of the cobwebs of your basic networking terms. A little bit of some basics, security terminology. I'm not going to go through all the definitions. I'll leave that to you as a little bit to brush up and get up to speed. We'll also look at some of the potential, maybe some best approaches. Now, granted, this is just the first high-level brush. We'll go into a lot more detail in all these issues later, but being Chapter 1, you're going to get a little bit of everything just to give an overarching look at security. Now, we'll look at legal issues. We'll look at what kind of resources are available to us. So, not sure which is the best place to put my face here. We'll go from there. So, the internet, we love it. Some of us hate it. But the advent of it has brought a whole lot of avenues for data networks to be compromised or data being ripped off. Congress and legislatures have been working probably every single year trying to put new laws and stuff in place to try to prevent identity theft, try to reduce viruses and worms, but I think as fast as somebody can put a policy in place, somebody's found a way around it. Same thing with new products, new technology, and things of that nature. You put out new software releases, somebody's found a way around it. New hardware releases, somebody's found a way around it. So that's really the world we're in. And this classes just kind of give you a little bit more in-depth knowledge of what can we do. So let's get to the basic of the network. Because one of the things that we need to worry about is what are the physical network that people can utilize to get access to our data. So we're going to make sure you understand basic network structure, dust off some cobwebs on data packets, IP addresses, URLs, what a MAC address is, some of the protocols that are used to communicate on a network, some of the basic utilities that you can use to get information, and your wonderful OSI model. Some of you that have had the networking class, and hopefully all of you have. So the basic structure of a network, basically what's the purpose of a network? It is for communication. How do we get from one computer to talk to another? Some of the parts that are in here, you've got network interface cards. That's the port in a computer that allows some kind of network media, Ethernet cable to connect to. It connects to a hub, a switch, a router. Firewalls are used to try to isolate certain data or users from entering or leaving your network. So hopefully all these terms are starting to go like, oh man, I thought I'd never talk about a router again. Well, guess what? If you're going to stay in the IT business, either whether it's security or in networking, you're going to deal with all these. Now, network architecture just basically says, how do I connect these devices together? How do I connect a switch, a router, to a hub, to a PC? That connection is your network architecture. You've probably heard us talk about mesh networks, if you remember that, partially mesh network, point-to-point networks. All of those are architecture types that will allow different devices to connect to each other. Now that I got everything physically connected, I got to send data between two computers. Whether it's two phones, two telephones, two computers, an iPad to a mobile phone, all of that are still computer devices as far as network design is concerned. Now, how is that data bundled? It's put into a data packet. Now, this data packet provides all the data and transmission information necessary. It's eventually whatever data, if I'm sending a novel War and Peace, eventually that's going to be converted into ones and zeros, into binary. And no, I'm not going to have you do decimal to binary conversions. Now, these packets can range anywhere from 32 bytes to 65,000 or more bytes. That's the physical size of it. They round up to 65,000. So now in that packet is some information that's crucial for security. Source and destination addresses, IP addresses. What is the size of this packet? So is it 32? Is it 65,000? What is the size and the number of bytes that are going to be sent? What type of packet is it? Is it an Ethernet packet? And then there's data and other header information. So you got the data that you're trying to send, a page or two of War and Peace, and it's encapsulated with source and destination IP address, attached at the back end of it, some kind of security to make sure the whole packet gets sent and received correctly. So that's that header information that's included. So we're not going to get into details. You've already been through this, but at least remember that this stuff did exist. Now, an IP address. There's two different types, IPv4 and IPv6. IPv4 uses four 3-digit dotted decimal location, 107.22.98.129. That's a dotted decimal notation. So each of those 3 digits, it's made up of what? 3 digits makes it how many bytes? But just keep in mind, when you see an IP address, an IPv format, it is always in this 4 3-digit number. The digits range between 0 and 255. Now, in this, these IP addresses, IP4 addresses, as time went on, the number of addresses started dwindling available to devices. They needed to come up with different ways of organizing these so that they can kind of extend the life of an IPv4 address. So one of the things they did was they kept they put network classes A through E. This first octet here tells you which class it is. And we're not going to go through all the different classes. Just know that there are certain classifications. Most of the ones that we deal with are A, B, and C. A are for very large companies. B is for middle-sized companies. C is for smaller companies. And then D and E are used for research and communication between different transmission protocols. Now, some of these addresses, to extend the life of the IPv4 address ranges, they created IP addresses that are public and private. Private IP addresses cannot be routed on the internet. So I can route it inside my network all I want, but the second I want to go to another computer outside the internet, I've got to go through a router, and somehow I've got to convert that private address into a public address. And part of that, these address ranges in these classes tells me for class A, let's say the private sector is any address that starts with 10. So it's 10.000 to 10.9, 255.255.255 is the range of private addresses for a class A. There's a range for class B and a range for class C that are private and public. Now, IPv6, to get rid of a lot of those rules and regulations, they created a 120-bit address. That is huge. So I go from 32-bit addresses in IPv4 to 128 bits. So now I've got billions and billions of available addresses for devices. And to make that addressing scheme easier or smaller to deal with, is that number is in a hexadecimal format. And that's what you see here, 3FFE:B000. All of this is hex. And if you remember, there are rules for how can I truncate or not have to print or type as much of that address. So when you see this :2, there's supposed to be 4 hex decimals between the colons. But when I see this, that means there's 3 leading zeros in front of the 2 and 3 leading zeros in front of the C. But just ways of shortening that address. Now, we're not going to get into this. You've already been through that pain. But just remember your IPv6 information. Now, a URL. A URL is basically just a text-based web address. You know, he mentioned the authors, that's the author's website. But what has to happen to be transmitted in a network, it can't be text. It's got to be a binary address. Well, that address is done by a protocol done by the domain name service servers that'll actually say what IP address is Chuck Easton's website app. So this DNS server translates URLs into actual IP addresses that can be used by the internet. Now, remember, there are several different addresses based on the different layers in the OSI model, which we'll get into a little bit later. I know, I thought I'd get away from it. When I'm talking about my physical address, that is a MAC address. So every network interface card, every NIC, has a unique MAC address. It's a unique number that contains 6-byte hexadecimal numbers, where the first half is the identifying the manufacturer, and the second half of it is a serial number, sequence number, so that you can pinpoint which manufacturer and which part of their inventory that network interface is. Now, of course, there has to be a protocol to convert IP addresses to MAC addresses, and that is done by the Address Resolution Protocol, the ARP. So that protocol, hopefully based on how long it was ago when you had your networking class, these things should start making sense, or at least dusting off some cobwebs. If for some reason that doesn't, send me an email, send me a text, and we'll find a way to get you back into the swing of things. Now, there are also, as far as communicating between different devices, there are different protocols, different rules to communicate and do certain things. And being in security, guess what? Some of these protocols have loopholes or avenues into the network that allow people to get in and steal information. Some of the examples you see here is FTP, Secure Shell, Telnet, DNS, POP3. All of these should start, dusting off some dusting off some cobwebs as far as remembering that we had these before. Now, some of the tools that were available to us to verify network connectivity and getting information from the network, these are 4 of them out there. IPconfig, you can type that in on your PC and get what's your IP address, what's your MAC address, what's your IPv4, what's your IPv6 address. The ping says, can I communicate with an outside device? So it sends a message expecting a reply within a certain time frame. So that gives you away. I can use traceroute, trace RT. It says, I want to trace how this packet goes between different devices from point A to point B, and give you a report of how long it took to get there. Or you can type in the netstat command, which then says, hey, what's the status of my network? What is going on on my PC? What do I know about? So those are some of the basic utilities. Now, hey, here's our friend, the OSI model. Now, OSI model has never been implemented, but it's good for instruction. Now, I don't think I'm going to quiz you on the different layers, but just know that this model exists, and if you're going to stay in the networking IT arena very long, you're going to run across this model, at least as far as a means of communicating with different vendors, and so that they've got a set of rules to talk about. And you can see the protocols as far as at which layers everything applies. So you've got the physical data link network. You can see at the network layer, that's where you've got your IP address. Here you've got at your data link layer, this is where you've got your MAC address is identified. And then as you go up, you start seeing different aspects. How's the data going to be presented? Which applications are you running? Am I running a mail server? Am I doing a file transfer protocol? Am I trying to communicate between devices? So each one of these layers has applications and a function that both communicate on both sides. So they're all talking by the same rules. So the question is, what does all this mean for security? Well, basically, there are 3 points of attack in any network. It's either one, the data itself, because there's flaws in that. There are network connection points. Is there a loophole or a weakness at where all these all these networks come together? The router, the hub, a server maybe, or the people themselves. Is somebody leaving their password, try to find a good place, out where they can see it? Now, if I'm trying to figure out, okay, how do I know if I've got a threat to my network? There's usually different points of view as far as what are security threats. But sometimes that point of view, that attitude, can lead to some poor decision. Now, two ends of the spectrum is, there's no problem, nothing to worry about, I'm not going to put any security at all. Or it's on the other end where it says, everybody, every hacker are experts. They're not just, high school kids or grammar school kids that just lucked into it. These are experts. These are skilled, trained experts that are out to break in and steal my network. So you end up putting so much security on your network that nobody can get into it other than the system administrator. But those are the two opposite extreme. Don't worry about anything, or make sure you lock down everything. Now, this no real threat kind of fosters a laissez-faire, I don't care attitude about security. The trouble is it makes you be reactive versus proactive. So you don't do anything until somebody breaks in and steals something. Then you decide to catch up. The question is, what's the problem? I don't put any measures in place until somebody broke in. Even though it's all over the news as far as what kind of issues and problems security networks are having, this has, most people say, well, I won't worry about it until it happens to me. Of course, if they steal everything in your business, you may be out of business. You got to make sure you avoid this at all costs. You need to have something. You got to do something to make it a little bit harder for people to break into your network. Now, the other side of the spectrum is the world's full of hackers are out to get me. Yeah, they exist. But not to the extent that we see on the internet. More than likely, it's not very skilled, or at least lesser skilled. There are more of those than there are high-skilled hackers. And the lesser skilled looking for small companies, mom-and-pop shops, just trying to get in. And basically, they're just trying to get access to higher profile network. So now the only practical approach is finding a nice moderate, some in between, some way of assessing your network and the data you have to decide how much security do you want to put into your security. I mean, there are several different types of threats. The three major categories: intrusion, blocking, and malware. There are different types under each one of these. You want to pay attention to what these are when you go through your reading and see what are they, what did they do, what is cracking, what is denial of service, what is distributed denial of service. So you need to understand, I think this should be keylogger, but so there are different threats out there, and you need to decide, what am I trying to protect my data from? Now, some of the questions you want to ask yourself is, what are the realistic data? What's my data? What am I trying to protect, and what is the most likely attack to this network? Where are we vulnerable? Those are, and then again, does anybody really want to break in? What do I have to steal? Now, granted, everybody's got something, but the question is, as an administrator, you need to decide all of these questions and say, what is the likelihood of that attack? Now, some of the factors you got to worry about? What is the attract? How attractive is my network? What's my business, and how attractive is that information that people want to get into? Banks, credit card companies, stealing credit card numbers and identity theft. Those are big attack for the major players. So it boils down to how attractive it is. What's the nature of the information? How much traffic goes into that network? If I get a lot of traffic, that could do two things. One, it's maybe easier to slide in because you're one amongst many. But if it's based on how much security devices, how many devices are in place to keep those people out. Now, sometimes we'll go through is what they call a threat assessment. And basically that's putting some kind of numerical value on how attractive it is to attach, what kind of information do I have, what kind of security devices am I willing to put in place. And then I decide, okay, what is my vulnerability? What is this, what is my number? And what is my score to say, do I need to do more? Now, if you've got a very attractive network and your invitation's high, but I got no security devices, guess what? You may have 10, 10, minus 1, so that makes you get 19. So all of a sudden says, whoops, my vulnerability is very high. But if I've got, information contacts of 5, security devices is a 10, then all of a sudden this number's low, and I'm looking for a vulnerability as low as I can get it. Because there's some point where the amount of security put in place has got to equal or balance out. Because if I put too much information into my security protection, I may take away from that attractiveness of the information, that I'm trying to protect. Now, here are some of the other terminologies you're going to have to get familiar with. So you're going to take a look at looking at a lot of definitions. And in this chapter, being chapter 1, there's going to be a lot of new terms. Take a look at it. I may post, I know the textbook has a glossary. Whether I want to put in something to help you test your terms, let me know in the feedback on the chapter in your reflection journal, or send me a text if you want me to put some kind of quizzing tool on your terms. Now, some information that are helpful for terminology. Here's a couple that you can verify. But now the question is, how do I want to approach network security? I want to be proactive versus reactive. And I want to, for the time with the perimeter devices, those are all on the outside. But it still says somebody can get in and deal with my internal device. Now, how do you think that's going to happen? Well, maybe it's an internal person in the organization that is causing the problems. What you want to make sure is you set up more of a layered approach or a hybrid approach, where I've got both perimeters, something that's preventing people in, and I want to put something on the inside, either on the individual devices, computers. So it ends up being a combination of multiple techniques to give you the best solution. Now, there are several laws out there that deal with network security and data. Some of these you're familiar with, but it basically says if I'm dealing with the government, I've got to have certain rules and regulations set up. So these three are big. The HIPAA is what? Your medical, Computer Security Act of 87. So as you can tell, in 1987, we've been trying to put laws in place for a long time to protect the data that we have. Now, some of the resources that I think you want to make sure you're probably going to use a lot in this class is these are at least, I would look at least three. The Microsoft Security, maybe I'm not a big Microsoft fan, but I think CERT F-Secure and SANS Institute are 3 very good resources. Check them out. You're probably going to get some homework and stuff. You're going to be using those resources quite a lot as we go through the semester. Now, so in summary, we look at most common dangers: viruses, worms, Trojan horses. There's definitely some basic terminology, hacking and security terms. Take a look at the hacking terms deal with the people. Security terms deal with devices and policies. Now, some of your approaches, you got proactive, perimeter, layered, and hybrid. Those are some of the ones you want to do. Some of the legal aspects, those are definitely 3 of the major laws that you're dealing with, and then resources available to you to help you do this in the future. So hopefully it gives you a very high level. We're going to go into a lot more detail in all of this later, but this is chapter 1, high level introduction. Get your feet wet, dust off some cobwebs in your networking terms, and we'll go from there. Talk to you later. Bye-bye.